Hi, this is Ms. AB, and in this video I'm going to do just a few of the problems from the last part of the 5.3 assignment on solving quadratic equations by graphing and factoring. So you need this information that's on page 6 of the worksheet in order to do the problems on page 7. We also talked about these in the week 11 assignment on factoring. So there's special rules or formulas that you can use if this is the form that your trinomial is in or your polynomial is in. So if you just have a squared minus b squared, there's no middle term, most likely you can factor it as a plus b, a minus b. If you have something set up that you're not sure how to factor, and you can see that if you took the square of the first term and the square of the last term, square root of each of those, and multiplied by 2, you'd get the middle term, then that's set up as a perfect square trinomial. Those are a little bit harder to notice, but if you can't factor in a regular way, you might want to see if it's a perfect square trinomial. So the easier one is the difference of two squares. If there's no x term, that's probably what's going on if they ask you to factor. So in this one, first you would solve by subtracting 1, set it equal to 0. You have to do that first. And then you can factor after that using this form here. So the way you use it, if you have 9x squared minus 1, you have to figure out what is squared minus what is squared. So in this one, we have 9x squared minus 1, and then it's equal to 0. So it's something squared, so rewrite this as something squared, which in this case would be 3x squared, because 3x times 3x is 9x squared, minus something squared, which would be 1. If you can get it in that form, then in this one, this would be our a. Our a would be 3x, and our b would be 1. So then you would reuse this side of the formula for special products and factors and put the 3x plus 1, 3x minus 1. Now you can also just put your two sets of factors. Remember, this is 9x squared minus 1. And you could say, well, I know that when I FOIL it back, I have to multiply first times first. That's going to have to equal 9x squared. So how could I do that? It's not just x and x, because that wouldn't give me the 9. So if I did 3x times 3x, that would equal 9x squared, so that's good. Then my last term is 1. What are the factors of minus 1 so that when you add them, it equals 0, because there is no middle term, so that's like 0x. So it happens that the factors would be negative 1 times positive 1. So put in a negative 1 in one of your sets of parentheses and a positive 1. Now, when you set these equal to 0, your factors, you might get a fraction, and that's just fine, like they did in this one. Alright, so I'm going to look at one of the problems on your worksheet before we look at the other type of special trinomials, the perfect square trinomial. But let's just look at 10 and 12 are both going to fit this difference of squares type thing. It doesn't look like it yet, because in 10 it's not yet set for 0. So I would have to subtract 9 from both sides, and then I would have 16x squared minus 9 equals 0. So you can look back and say, well, let's see, what would the a be? What's being squared in the first term, and what's being squared in the second term for b? Or you can just set your two sets of parentheses and say, okay, I need something squared, or something times x x has to equal 16x squared, because when I FOIL it back, first times first has to equal the first term. So you could try 4x and 4x. That's equal to 16x squared. And then for your, what's going to be 1 is going to be minus, and 1's going to be plus. And then what are the factors of 9, negative 9, that add up to equal 0 for the middle term? So figure out what that is, put it in, and then solve. You will get fractions for your answer. Now in 12, it's already solved for 0. It's already got everything on one side, but we need to factor this first. It'll be a much easier problem if you figure out what you could take out of every term. What is the greatest common factor? happens that that is 5. So I'm going to factor this by 5 and this by 5, and that leaves me with 100x squared minus 9 equals 0. Now we can divide both sides by 5, and if we do that, then we just have the 100x squared minus 9 equals 0. Now, this is also something squared minus something squared. So it's going to be very similar to 10. You're going to have two sets of parentheses, something x times something x for our first and our first, and it'll equal 100x squared when you multiply it back, and then figure out what would go into, for the last times the last, to equal negative 9, and we just had a negative 9 problem in number 10, so it'll be the same factors. Now I want to go back and look at the perfect square trinomial model again. It looks a little different. It might look like example B here. Now, first thing that they did is first they divided everything by 2, factored out a2, and then they were left with this right here. 4x squared minus 20x plus 25. Now, you can just put your two sets of parentheses and do trial and error. Because there's a number in front of the x squared term, it's going to be a little trickier. But you could say, I know it's going to be something x times something x, and it has to equal 4x squared. So I could try 4x times 1x, or I could try 2x and 2x. And then you have to plug in something times something for the last term that'll equal 25. Well, I'm going to try 5 and 5. Now, it's a positive 25, but a negative middle term, so I either have to get a positive 25, I either need a positive 5 times positive 5 or a negative 5 times negative 5. And because the middle term is negative, it's probably that. And then I would definitely FOIL this to check, because I just used trial and error to figure this out. So now I'll multiply. I've got first term times first term. That would be 2x times 2x is 4x squared, so that's good so far. Then the outer would be 2x times negative 5. 2x times negative 5. That would be, put the 2 and the negative 5 together, that would be negative 10x. Then do the inner times the inner, negative 5 times 2x. Negative 5 times 2 is negative 10, and then we have an x again. And then the last term times the last term is negative 5 times negative 5. That's a positive 25. So if you add your two middle terms together, they're like terms, and then we do get what we started with. Now, I might not have got it the first time. I did, but sometimes you might have to do it a couple times before you get the right answer using trial and error. But if there's a number in front of the x squared term, and you don't want to use, or you can't use, the perfect square trinomial model, because sometimes that's not what it is, then trial and error is your best bet. So when you do numbers 9 and 11, you're going to look for what are the factors. So figure out what times what would equal 4x squared, and then what times what equals 25, and plug it in. Now look at 11. 4x squared minus 20x plus 25. It's right there. So when you do number 9, first thing you want to do is get everything equal to 0. So I'm going to subtract 12x from both sides. Now that leaves me with 0 on the left side instead of the right, but that doesn't matter. 9x squared minus 12x plus 4, and then it does happen that it is a perfect square trinomial, but that doesn't matter. We can do it this way. We'll do trial and error. You're going to figure out what x times what x equals 9x squared. So there's not that many factors of 9. It's either going to be 9 times 1, 9x times 1x, or it'll be 3x times 3x. Probably going to go with that one. And then we have the last term is equal to a 4, so you have to figure out the factors of 4. And because the middle term is a negative 12x, that means this is going to be a negative and a negative. So you just have to figure out what goes in here, these boxes, and you need to FOIL it to check. Now don't forget that once you get your factors, you still have to find x. I didn't do that on any of these, but I did on the examples. So once you figure out what your factors are, then you still have to set each factor equal to 0 and solve, and you might get the same answer. So the answer for this example is just 5/2 or 2.5 or 2.5. You don't actually have to write it twice. You get the same thing each time. But do make sure that you don't forget that last step of finding what x is. All right, hope this helps. Thanks a lot. Have a wonderful day.